We had two main objectives. Basically, we wanted to understand for those compounds released into the air during the use of the product, what fraction of the low vapor pressure VOC compounds in those released to the air would remain in the air and be available to form ozone in the air shed versus having another fate, either degradation in another compartment or being ejected downwind where they could ultimately form ozone in that compartment. And the second objective was for those compounds disposed of down the drain during use, what fraction of those might be released either directly from the wastewater treatment facility or from the effluent stream of the wastewater treatment facility into the air, and then of that fraction released to the outdoor air, what was then available for ozone formation. We evaluated existing models. I have worked extensively with the Caltox model, and so we thought that would be a good one to consider. We also looked at the Foster model, which had been applied to this same question in Canada. We thought that was another very appropriate model to include on the multimedia side. In the wastewater treatment side, we looked over the literature and really realized that most of the models were focusing down on two fundamental modeling approaches, and we evaluated and compared those two and really tried to see what was considered the state of the art. We had some initial surprises when we first modeled the compounds in the multimedia fate and transport emission to air using Caltox. We had read the paper by Foster, which had found a significant fraction of the compounds being degraded in surface water. We were not finding the same results when running the Caltox. We were finding a much greater portion reacting in the air, but then we really started to dig down into the models and see that the differences were related to the amount of rainfall and the amount of surface water between the landscapes. And then we further realized that for this application, it wasn't even appropriate to really assume continuous rainfall as the Caltox model was initially parameterized for, but rather to consider the summer as a completely dry season. So that was a bit of a surprise. We were expecting a greater fraction to be removed from other processes. It's just startling how vastly different the fraction of chemical available for ozone formation is if it is released down the drain versus volatilized into the air, really highlighting the importance of understanding that, where the chemical goes during consumer product use. I think that it would be important for ARB to have a good understanding for a wide variety of consumer product types, what fraction is going into the air versus down the drain. Also, I think that there should be information about what fraction of chemicals in commerce are used in the various different types of consumer products so that the models could be applied to the appropriate volume of chemical to be able to create an overall picture of what might be available in the airshed.